So section 11.2 focuses on the method called completing the square. And to visualize this, what I'm going to actually do is I'm going to draw a square here. But our goal here is to basically, just using the x squared plus 8x, create a perfect square so that I can solve, basically I can turn 11.2 back into an 11.1 question. Okay. First thing, just as a recap, this will not factor. There are not two factors that are whole numbers to multiply to make 10. Combined to make 8. That does not mean this is not solvable. It just means that factoring is not going to be the method we use. Okay? So, well, what do we do? Well, since we're only going to use the x squared plus 8x and not really the 10, we move that first. That's our first step. Use only the ax squared plus bx. Move the c. Okay? So I'm going to minus 10 on both sides, and just have x squared plus 8x equals negative 10. Well, our goal is, I want this to turn into some group squared. I want this to be a perfect square. Well, I know whatever it is, x times x is going to give me the x squared. Okay? And I'm going to actually add a step in here that I wouldn't normally have. I'm going to have two groups that are identical, so that ultimately I end up with one group squared. Okay? Well, I know that x times x is going to make x squared, so that's the easy part. But I need these two numbers to combine to make the 8, and I need them to be the same number. So what do? We basically use b over 2. I take the b term and I cut it in half. I put a 4 on each of these. What that does is basically I can split this so that if it were to distribute, we would have x times x is x squared. 4x and 4x would give me the 8x. Okay, we took the 8x and we basically split it, 4x and 4x, and it must be x plus 4 squared. That is the perfect square. That is our goal. The issue is this does not turn into x plus 4 squared. It's missing something. It's incomplete. It doesn't have the c that we need. So what do? We give it what it needs. We complete the square. We complete the square by adding this number, 4 times 4 is 16, to this side. And if I do it to one side to keep the equation balanced, we do it to the other. So now I have all of this x squared plus 8x plus 16 can turn into x plus 4 squared, and negative 10 plus 16 is 6. So this was step 1, moving the c. This was step 2, completing the square, adding that 16 on both sides. And step 3, we can now solve this using inverse operations. We basically have turned this back into an 11.1 question, meaning I can undo the squaring by square rooting. The square root of x plus 4 squared is just x plus 4. The square root of 6 is plus or minus root 6. And last, we can subtract the 4, getting us x is equal to negative 4 plus or minus the square root of 6. This is the easiest way to solve this question. I know it's kind of new, so they're going to kind of ease in on this, but the idea is we take that b term, we split it in half, then we square it and add it to both sides. This whole group can turn into that perfect square, and then we can solve using inverse operations. Some of you are still not sold on this. You're like, no, I love me some quadratic formula. So I'm going to throw it out again, even though this is not the way I would do this. You could do x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 10, all divided by 2 times 1, and simplify the mess out of that thing, and eventually you will get this answer. But that is not the easiest method. Once you get good at completing the square, I'm telling you, these will simplify very quickly. Okay. Plus, if you go into the higher level mathematics, if you're going on the trig and pre-calc direction, you have to be able to complete the square. You cannot actually, there's going to be questions where you have to complete the square to get the equation in the right form. You cannot just run it through a quadratic formula. So this is great for now, but it will not work forever. You need to know how to complete the square. Okay? This is pretty much the most complicated thing I'm going to have that you're going to see on the test. You'll have some harder ones in the homework. We'll talk about those as we keep going. Let's start with what your homework's going to do. They're just going to go, what constant do you need to get the perfect square? Well, I have x squared plus 4x, right? And so remember, I want a perfect square. So first, what's going to make that x squared? Well, x times x, right? Second, I'm going to take that b term and I'm going to split it. 2x, 2x. I know that it's going to be x times 2 to give me 2x, and x times 2 to give me 2x. I know what my group is going to be. It's going to be x plus 2 squared. That makes a perfect square. The problem is there's a piece missing. Because all of this, x squared plus 4x, doesn't turn into x plus 2 squared. It creates that c at the end. It creates what at the end? Well, it's that number squared. If I distributed all this out, x times x would be x squared, 2x and 2x would be 4x, 2 times 2 would be, that is what we need. The c has to be a 4 for it to be a complete or perfect square. I like the visual. I'm not going to keep solving them this way, but I just want you to see the reason I like the visual is because it literally makes a square, right? What is a square? Well, all four sides are the same. And look, all four of these sides are x plus 2, x plus 2. All four sides are the same. This is a perfect square. We give it the c, we give it what it needs to complete that square, to fix the piece that's missing. Same with this one, t squared minus 2t plus c. What is the c? Well, I always say, well, what's the group? Well, it's that b term cut in half, so it's minus 1. Basically what we did is we split this into negative 1t, negative 1t. We figured out that t times t is t squared, and that t times negative 1 gives me negative 1t, t times negative 1 gives me negative 1t. That's what we just figured out. We figured out t minus 1 squared. We still need to figure out, what do I need to complete this square? Well, it's negative 1 times negative 1, or negative 1 squared. That negative 1 times negative 1 is a positive 1. That's the c this time. By the way, the c will always be positive in this situation, because if this is negative, a negative times a negative, that'll be positive. If it's positive, positive times a positive will be positive. So c will always be a positive number that we add to complete the square. This one's a little trickier, but it's the same skill. I have m squared plus 5m. Can I split 5 in half? So you're like, oh yeah, make it 2.5. Well, I'm okay if that's where you're at for now, but I would just encourage you to leave that as a fraction. b over 2 would be 5 divided by 2. We could check that right now. Does 5 halves plus 5 halves give us 5? Well, it gives us 10 halves, or 5. There you go. So that number plus itself makes the 5. What's the c, though? Well, the c is that number times itself. So what is 5 halves times 5 halves? How about 25 over 4? That would be the c we need. That's a little more complicated than I would be doing on the test, but those of you who are going to trig and pre-calc, man, we're going to be using numbers like this all the time. If you want to make that 2.5 and this one's 6.25, I'm not going to freak out about that at this point. Some choices there. This is one where I don't want a decimal, because I'm going to take this and I want to divide it by 2. But what is 2/3 divided by 2? Well, we need to know that that means the same thing as 2/3 times a half of something is like dividing it by 2. So what is it really? Minus 2 over 6. I think we can simplify that. How about 1/3? Well, that makes sense that half of 2/3 would be 1/3. So what is my c? What completes this square? If we were to distribute x minus 1/3 out, we get x times x is x squared. Minus 1/3 gives us 2/3. But what is minus 1/3 times minus 1/3? Positive 1/9. That would be the c that we need to complete the square. So that's where the homework's going to start out, is just having you figure out the c. The first example I did was kind of more what I'm going to expect to be able to do on the test. Let me just deal with an easy one, and then we'll kick this up a notch. Like, why is this one an easy one? Because I don't have to complete the square to solve this. In fact, I wouldn't. If I was given this question and somebody said just solve it, the first thing I would always check, can this thing factor? Well, what multiplies to make x squared? What multiplies to make 5? Combines to make a negative 6. I could use the zero product property and get that x equals 5 and x equals 1. And I would solve it like that all day long. But we already saw some questions don't factor. So what do? You're like, well, that's why I learned the quadratic formula. Sure, we'll get there. Settle down. But actually, a method that is easier than the quadratic formula is completing the square. So that's what I'm going to focus on here. How do I complete the square? First, move the c. Why? I'm only using the a and the b to make my perfect square. Second, what is that perfect square? Well, it's x times x, and it's this middle term divided by 2, so minus 3. But if we were to distribute that whole mess out, I would get x squared minus 6x plus what? That is just that number squared. Negative 3 times negative 3. This needs a plus 9. The minute we give it a plus 9, that is called completing the square. We're giving it what it needs to become that perfect square. But I can't just add 9 because it feels good. We have to make sure what we do to one side to keep it balanced, we do it to the other. Negative 5 plus 9 is 4. Now I can solve this using inverse operations. But this is the big complicated thing that's terrifying us, completing the square. And I understand it's not the easiest way this time, but it will be on some future ones. So now what do? To undo the squaring, we square root both sides, left with x minus 3 on the left side, square root of 4. Do not forget the plus or minus with the 2. And so last, when I add the 3, I get 2 plus 3, or 5, and I get negative 2 plus 3, or 1. Question: did the answers change? No, and they shouldn't. This is a different way of getting the same answer. But let's be clear again. I would not solve this by completing the square unless I had to. I might give you one like this and ask you to complete the square just because it's a simpler completing the square question. Okay? But if I just ask you to solve this and you can factor it, factor that sucker all day long. And my last scenario is if completing the square is not easier, if it doesn't factor and it doesn't complete the square nice, then we will use the quadratic formula. Okay, but I'm going to save that for the next section. So we will use the quadratic formula, but I'm going to go ahead and apply some completing the squares to some more complicated questions, and then we will get to complete quadratic formula in the next section. Solve this by completing the square. Let me give you a hint right now on this one. Unless I was told to, which I am, I would not do this one by completing the square. I'm like, well, how do you know? Well, generally, I don't like to complete the square unless I have ax squared plus bx plus c, and I want that a to be a 1, which it is, 1k squared, and I want the b to be even. Why do I want the b to be even? Well, we're going to split that in half. and I don't feel like splitting an odd number in half. Not that we can't, it's just it's a little more work than it's worth, and it might be easier to use the quadratic formula on this one. But let's still see how completing the square works. First step, I want A is 1, I want B even. Unfortunately, that's not happening, but we move the C. So I'm going to add the 1. That leaves me with k squared plus 5k equal to 1. Now we go to complete the square. What is my perfect square? Well, it's k plus half of 5. How about 5 over 2? I go to complete the square now. I go up here and we will add, so what was it? Our group is x plus b over 2 squared, and then we add that b over 2 squared to both sides. Basically, I'm going to have 5 halves times 5 halves, or 25 over 4. Now on the right side, I've got 1 plus 25 over 4. Please feel free to use a calculator for that. But if you're not sure, 1 plus 25 over 4, common denominator, about 4 fourths, plus 25 over 4, about 29 over 4. Okay? Now we can solve, this whole step right here, all this in right here, is just called complete the square. Figure out what the group is, b over 2 squared, and add b over 2 squared to both sides. Now we can solve using inverse operations. So I would square root both sides. K plus 5 halves equals, do not forget from the square root we get a plus or minus. The square root of 29 stays ugly. The square root of 4, about just 2. And we are one step away. I subtract 5 halves and get the k is equal to negative 5 halves plus or minus the square root of 29 all over 2. Or, since they have a common denominator, you could do negative 5 plus or minus the square root of 29 all over 2. That would be the same answer you got if you used the quadratic formula. Let me be clear again. This is not the easiest way to solve this, but it still works. And it's really not that bad. You have to cut an odd number in half and square a fraction. You will survive. If you're going into stats, don't worry about this. If you're going into trig and pre-calc, you must be able to solve this by completing the square. We're going to do 2 of these, are about as complicated as they're going to get. The issue here is that is not a 1x squared. I do not want to complete the square. I don't want to figure out a group when that's not a 1x squared. So what do? We divide both sides by a. Everything gets divided by the 9. You're like, why would we want to do that? Because now this will be easy to complete the square. Step 2, how do I complete the square? What's my group? X plus b over 2. 2 divided by 2 is, add what to both sides? B over 2 squared. 1 times 1 is not 2. Please add 1 to both sides. Equals negative 5 ninths plus 1. Negative 5 ninths plus 9 ninths, about 4 ninths. We undo the squaring by square rooting. X plus 1 is equal to, the square root of 4 is 2. The square root of 9 is 3. Do not throw away points by forgetting the plus or minus. And last, we subtract the 1. X is equal to negative 1 plus or minus 2/3. I'm I'm okay with that. We could actually write that out. Negative 1 plus 2/3 would be negative 3/3 plus 2/3 is negative 1/3. There's the first answer. Negative 1 minus 2/3, negative 3/3 minus 2/3 would be negative 5/3. So that was really kind of our best answer for that. You could solve that by the quadratic formula. I would. I wouldn't go through all this mess. But we can still solve it by completing the square. You need to know this for the trig and pre-calc. Plus, those of you who just are, oh man, you're in love with the quadratic formula, wait till we get to the next section. You got to give credit where it's due. The quadratic formula would not exist without this process. Okay? I'll show that to you later. Let's keep going. These last couple, like I said, are really, this is harder than what you're going to see on the test. But first, isolate the ax squared plus bx, which means move the c, move the 5, just like we did before. 4p squared plus 8p equals negative 5. Second, we do not like that 4. That is not going to be easy to complete the square. So we're going to divide everything by. So we have p squared plus 2p equals negative 5/4. We can now complete the square. This is now, we've created all this mess on the right side so that the left side is easy. What is my perfect square? P plus half of the b term squared. Going up here, 1 times 1. Negative 5/4 plus 1 would be negative 1/4. We can now solve this using inverse operations. The square root of p plus 1 squared is just p plus 1. On the right, what is the square root of negative 1 over the square root of 4? Well, the square root of negative 1, we should know from the previous sections, is I over 2. Do not forget, from the square root, we get a plus or minus. And last but not least, subtract the 1 on both sides so that p is equal to negative 1 plus or minus I over 2. Once again, definitely we'll have these in the homework, prepping you guys for that trig and pre-calc. This would be a little harder than I would test you on. The last couple are something that I could put on the test though. I think they're a little dirty, but here's the issue. This is not ready for any of our methods. It's not in standard form. So I want it in this form. So you'd have to take the r and distribute it. Then add the 1 to both sides and get it back standard form. Because now I can complete the square or factor it or run the quadratic or whatever I wanted to from that form. Same with this one. I would get it in standard form. I would distribute this, x squared plus 4x plus 3. Moving the 5, I get x squared plus 4x minus 2. In this form, it's going to be way easier to solve. If it factors, I would factor it. If it doesn't factor, both of these have an a of 1, a b that is even. This will be easiest to do by completing the square, meaning move the c, complete the square, add what to both sides after we cut that in half, negative 2 times negative 2. That's it. That's the hard part. I'm going to expect you to be able to do this on the test. The rest of it's easy. To undo squaring, plus or minus root 3, adding the 2, 2 plus or minus the square root of 3. This would be a fair question on the test. Same with this one. Move the c, I like to leave some space here to complete the square. Kind of thinking ahead. x plus what? Well, 2 plus 2 is 4. What do I add to both sides? 2 times 2 is also. That's it. That's the terrifying step. You need to know how to complete the square. We then do the squaring by square rooting. Plus or minus the square root of 6. So that x is equal to negative 2 plus or minus the square root of 6. Okay, we did a lot of examples there. Feel free to go over some of the ones. I still think these at the end might be a little harder. I might have maybe one of these on the test where it's not in standard form. But you will be expected to solve questions specifically by completing the square. Not on the crazy hard ones, because really that's not the easiest way. I'm not going to try to make you do it that way. But on some easy ones, and on some where the A is a 1 and B is even, this will be the easiest method. I will expect you to be able to complete the square.